Okay, so in this video we're going to be looking at finding the formula for the arc length of arcs around the circle and then applying this for a few examples. So really the problem here is to find this length L given an angle theta and the radius r for our circle. How do we find the arc length of this little region here? So to do this we can actually think about firstly the whole circumference of a circle. So just remember the formula for that. Circumference of a circle, that's just 2 pi times the radius. And now to find this length L, what we can do is just take the fraction of how far we've gone around the circle. So this is going to be given by the angle. So firstly we work in degrees of the arc length L. This equals the whole circumference times the ratio of the whole circle we've covered. And this, as we said, is the angle in degrees here divided by a full turn, which is 360 degrees. So this formula is in degrees. But this isn't particularly nice because we've still got constants, we've still got pi's, and it's quite messy. What we want is a nicer formula, and we can achieve that by using radians. So we also have a formula for radians, which is 2 pi r, the whole circumference, times the fraction of the angle. So now in radians, it's theta divided by a full turn, which in radians is 2 pi. And this is really nice because we see the 2 pi's are going to cancel. So we get this really nice formula where the arc length is just theta times r. So this is the formula for the arc length. So for example, if we're given a radius of say 5.2 and an angle in radians, this is important, if it's in radians, let's say 0.8, then the arc length with these parameters, we just multiply these two numbers together. So it would be 5.2 times 0.8. And you can plug that into a calculator. This will come out as 4.16. And this is, well, if we're working in centimeters, this would also be in centimeters. So this is just using the formula. So we're going to look at one more example, and it's going to be a bit more complicated. We need to think about the shapes we're dealing with. So I'm just going to wipe this off, and then we'll look at that. Okay, so now we're going to look at a bit of a harder example using this formula. I'm just going to sketch out a diagram. We're going to be looking at this sector of a circle. So it's just like a slice of a circle. And then we've got this arc length, and I'm also going to draw on this arc length. So these correspond to different radiuses, or radii. So I'm going to say this length is 3 centimeters, just from here up to here. And also this length is 2 centimeters from here up to here. Then we also need the angle. This we'll call theta, theta in radians. And then the problem is to work out, if we consider this region, I'll just shade it here. The problem is to work out the perimeter of this shaded region. So you've got these 4 sides. Well, we know this is going to be 2 centimeters as well, just by symmetry. And so we need to work out the length of this arc length and the length of this arc length. So firstly, if I just call this x and if I call this y, then the problem is to find the perimeter, which I'll call p. And this is 2 plus x plus y. So we just need to find what x and y are. So firstly, to find x, we just need to apply the formula for the arc length, and we just need to be careful about the radius that we choose. So for this circle, or this sector, we are considering this circle when it's got a radius of 3 centimeters. So it tells us that x is going to be theta times 3. And then let's find a formula for y. This is going to be the same formula actually, but now we need to be careful about the new radius because we aren't on this circle anymore, we're on this one. And so we need to think about the total radius from here to here. So we just add 3 and 2 and we get 5. So the arc length of y is equal to theta times 5. And so if we just plug this back in and do a bit of simplifying, we get the perimeter is 4 plus 3 times theta plus 5 times theta, which is 8 times theta. So 8 lots of theta. And it's nice because this is quite a general formula, but let's say if we're given a value of theta, if theta was 1.2 radians, then we can evaluate this. And then the perimeter comes out as 4 plus 8 times 1.2. And if you, I don't know, do the algebra or plug it into a calculator, then this is going to come out to be 13.6. And this was in centimeters, so the perimeter is also in centimeters. So this is just a nice little problem just to get used to using this formula.